Hi class, this is Dr. O'Connor. In this video I'm going to talk about some common acid-base reactions, and then we're going to talk about salt solutions. So let's start with some of the common acid-base reactions. We already have seen reactions of acids with hydroxide ion. So for example, here we have hydrochloric acid reacting with potassium hydroxide to produce water and a salt. This is a neutralization reaction. So what I can do is write the net ionic equation for this. Before I write that, let me go ahead and write the ionic equation. And we know that hydrochloric acid is strong. It completely dissociates. And of course our base here, potassium hydroxide, is a strong base. It also completely dissociates. And we have water, and potassium chloride is soluble in water, so this would be dissociated as well. Let's write our net ionic equation. Look here, the potassium and chloride ions cancel, and for our net ionic equation we end up with hydrogen ion plus hydroxide ion to give liquid water. So for any strong acid, strong base reaction, this will always be your net ionic equation. So let's go ahead and write an equation for nitric acid. So we mix some nitric acid with some sodium hydroxide. So let's write the equation for that. And so we know that we're going to end up with water and a salt. And in this case, the salt is going to be sodium nitrate. So I would expect you to be able to write these reactions. The next type of common acid-base reactions are those where acids react with bicarbonate and carbonate ions. So here we have our bicarbonate and our carbonate ion. Let's say we have some sodium carbonate, okay, and we have hydrochloric acid. And basically what's going to happen here is we're going to have obviously sodium chloride, which is a salt, and the formation of what we call carbonic acid. And let me go ahead and balance this. We have two of that. So this is balanced. So here's the thing. Carbonic acid is not very stable, and it decomposes to carbon dioxide and water. So I can rewrite this equation then as sodium carbonate plus 2 hydrochloric acids to produce sodium chloride plus carbon dioxide and water. Okay, so this would be the equation, the overall equation for the reaction of sodium carbonate with hydrochloric acid. Go ahead and take a look at those. And so anytime you have carbonate ion or bicarbonate ion, there will be the production of carbon dioxide gas and liquid water. And that's because carbonic acid is not stable. So it decomposes to carbon dioxide and water. You've also seen reactions of acids with ammonia. So we have ammonia plus hydrochloric acid, let's say. And what's going to happen here, the ammonia is going to pick up a proton and it becomes ammonium ion, and then of course we are left with the chloride ion. Okay, so other compounds like methylamine, okay, these are also bases. And the amines, they have that lone pair of electrons that are required for a base. So amines are weak bases. And so if I react this with hydrochloric acid, then again what's going to happen is the methylamine is going to pick up the proton and we'll end up with this. And of course the chloride ion. Okay, and this is what we call an ammonium salt, and this is called methyl ammonium chloride. So practice those reactions. These are all on page 311 through 313. So take a look at these. The next topic we're going to discuss is that of salt solutions. You would always think of a salt solution as being neutral, but that's not the case. Remember, salts that dissolve in water will dissociate into ions, and some of these ions can actually react with water to produce either hydroxide ion or hydronium ion. Some of them don't react. So what we're going to do here is predict whether a salt solution is acidic, basic, or neutral. Let's take a look at the situation where we have the salt of a strong acid plus a weak base. And what we're going to end up with is an acidic solution. We have hydrochloric acid plus ammonia. So what we're going to end up with is ammonium ion plus chloride ion. So we know the chloride ion is not going to react with water, but the ammonium ion will. And this is how that would work. Ammonium ion plus water. And we're going to end up with ammonia. This proton is going to be picked up by the water. So we'll end up with ammonia plus hydronium ion. So here we have an acidic solution. Now, let's take a look at the other scenario. If we have the salt of a weak acid plus a strong base, we end up with a basic solution. Let's look at the reaction between sodium hydroxide, that's a strong base, and acetic acid, which is a weak acid. And what we end up with is sodium acetate plus water. Now, the sodium acetate is dissociated as sodium ion and acetate ion. Sodium ion is not going to react with water, but acetate ion will. So here is our acetate ion plus water, and the acetate ion will pick up a proton from water to become acetic acid, and we're left with hydroxide ion. So this would be a basic solution. In the third case, if we have the salt of a strong acid and a strong base, we have a neutral solution. So if we react, let's say nitric acid, which is a strong acid, plus sodium hydroxide, which is a strong base, we end up with a salt and water. Sodium nitrate is dissociated as sodium ions and nitrate ions. And sodium ion will not react with water, and nitrate ion will not react with water. Why? Because then you would end up with nitric acid, which is a strong acid, and that's going to stay completely dissociated. So in this case here, we have a neutral solution. Now, some of you might ask, well, what if you have the salt of a weak acid and a weak base? Well, it's not so easy to predict whether the solution is acidic, basic, because both the cation and the anion are going to react with water in a case like this. So unless we have more information, we can't determine whether the solution will be acidic or basic. What will happen is the ion that reacts to the greater extent with water is going to determine the pH of the solution. So it can either be the cation or the anion. And the only way we would know that is if we were given the acid dissociation constants for both. Anyway, that takes care of this section. I'll be creating one more video on buffers, and that will take care of chapter 10. Everybody have a great day.